Good morning, my dear students. My today's topic is pulmonary circulation. So let us we will discuss about pulmonary circulation. Pulmonary circulation, under this pulmonary blood vessels, as because we know the circulation is dependent upon the blood vessels. Pulmonary blood vessels include pulmonary arteries, which carries deoxygenated blood to alveoli of lungs, and bronchial artery, which supplies oxygenated blood to other structure of the lungs. Now, what is pulmonary artery? Pulmonary artery supplies deoxygenated blood pumped from right ventricle to alveoli of lungs, comes under pulmonary circulation. After leaving the right ventricle, this artery divides into right and left branches, and each branches enters to the corresponding lungs along with primary bronchus. After entering the lungs, branch of the pulmonary artery divides into small vessels and finally forms the capillary plexus that is in intimate relationship to alveoli. Capillary plexus is solely concerned with alveolar gas exchange. Oxygenated blood from the alveoli is carried to left atrium by one pulmonary vein from each side. Now, bronchial artery. Bronchial artery arises from the descending thoracic aorta. It supplies arterial blood to bronchi, connective tissue, and other structure of the lung stroma, visceral pleura, and pulmonary lymph nodes. Venous blood from these structures is drained by two bronchial veins from each side. Bronchial veins from right side drain into azygous veins, and the left bronchial veins drain into superior hemizygous or left superior intercostal vein. However, the blood from distal portion of the bronchial circulation is drained directly into the tributaries of pulmonary veins. Now, physiological stunt. Physiological stunt is defined as a diversion through which the venous blood is mixed with the arterial blood. Components. Physiological stunt has two components. Number one, flow of deoxygenated blood from bronchial circulation into pulmonary veins without being oxygenated. It makes up part of the normal physiological stunt. Number two, flow of deoxygenated blood from the Bayesian veins into cardiac chamber directly. Now, venous admixture and wasted blood. So, physiological stunt results in venous admixture. Venous admixture refers to the mixing of the deoxygenated blood with the oxygenated blood. Fraction of venous blood which is not fully oxygenated is generally considered as wasted blood. Now, normal stunt level and its variations. Normal physiological stunt of venous blood to the left side of the heart is about 1% to 2% of cardiac output. In normal persons, it may increase up to 5% of cardiac output, which may be due to mismatching of ventilation perfusion ratio within physiological limits. Now, pathological increase in the shunt occurs in several conditions such as acute pulmonary infections and bronchitis, permanent dilation of the bronchi due to the chronic pulmonary infection and inflammatory processes. Now physiological shunt versus pathological physiological dead space. Here we will discuss about the physiological shunt versus physiological dead space. So physiological shunt is analogous to physiological dead space. Physiological shunt includes wasted blood and physiological dead space include wasted air. Both wasted blood and wasted air exist on either side of alveolar membrane and both affects the ventilation perfusion ratio. Now characteristics features of pulmonary blood vessels. The following are the characteristics feature of the pulmonary blood vessels. Number 1, pulmonary artery has a thin wall. Its thickness is only about 1/3 of the thickness of the systematic aorta wall. Wall of the other pulmonary blood vessels is also thin. Second, pulmonary blood vessels are highly elastic and more distensible. Number 3, smooth muscles cord is not well developed in the pulmonary blood vessels. Number 4, true arterioles have less smooth muscle fibers. Number 5, pulmonary capillaries are the larger than the systematic capillaries. Pulmonary capillaries are also dense and have multiple anastomosis. So each alveolus occupies a capillary basket. Number 6, vascular resistance in pulmonary circulation is very less and it is only 1/10 of the systematic circulation. Number 7, pulmonary vascular system is low pressure system. Pulmonary arterial pressure and pulmonary capillary pressure are very low. Number 8, pulmonary arteries carries deoxygenated blood from heart to lungs and pulmonary veins carries oxygenated blood from lungs to heart. Number 9, physiological shunt is present. Now pulmonary blood flow. Lungs receive the whole amount of the blood and it is pumped out from right ventricles and output of the blood per minute is same in both right and left ventricles and it is about 5 liter. Thus the lungs accommodate amount of the blood which is equal to amount of blood accommodated by all other parts of the body. Now pulmonary blood vessel pressure. Pulmonary blood vessels are more distensible and systematic blood vessels. So the blood pressure is less in pulmonary blood vessels. Thus the entire pulmonary vascular system is low pressure bed. Now pulmonary arterial pressure, systolic pressure that is 25 mm Hg, diastolic pressure that is 10 mm Hg and mean arterial pressure that is 15 mm Hg. Now pulmonary capillary pressure is about 7 mm Hg and this pressure is sufficient for exchange of the gases between alveoli and blood. Now measurement of the pulmonary blood flow. It is measured by applying Fick principle. Now regulation of the pulmonary blood flow. Pulmonary blood flow is regulated by the following factors. Number 1, cardiac output. Number 2, vascular resistance. Number 3, nervous factors. Number 4, chemical factors. And number 5, gravity and hydrostatic pressure. Now cardiac output. Pulmonary blood flow is directly proportional to cardiac output. So any factor that alters the cardiac output also affected pulmonary blood flow. Cardiac output is in turn regulated by 4 factors. Number 1, venous factor. Number 2, force of contraction. Number 3, rate of contraction. And number 4, peripheral resistance. Now vascular resistance. Pulmonary blood flow is inversely proportional to the pulmonary vascular resistance. So pulmonary vascular resistance is low compared to the systematic vascular resistance. So pulmonary vascular resistance is altered in different phases of respiration, and during inspiration pulmonary blood vessels are distended because of the decreased intrathoracic pressure. Now, nervous factor. Stimulation of the sympathetic nerve under experimental conditions increases the pulmonary vascular resistance by vasoconstriction and stimulation of the parasympathetic nerve, and that is vagus nerve, decrease the vascular resistance by vasodilation. However, under physiological condition, it is doubtful whether autonomic nerves play any role in the regulating the blood flow of lungs. So this is inspiration, that's decreased intrathoracic pressure, distension of the pulmonary blood vessels, referred to decreased pulmonary vascular resistance, and finally it is increased pulmonary blood flow. So chemical factor. The excess of the carbon dioxide or lack of oxygen causes vasoconstriction. The cause of the pulmonary vasoconstriction by hypoxia is not known, but it has some significance. If some part of the lungs is affected by the hypoxia, there is constriction of the capillaries in the aorta, that area, and blood is directly to the alveoli of neighboring area where gaseous exchange occurs. And number 5, gravity and hydrostatic pressure. Normally in standing position, blood pressure is lower. Extremity of the body is severe, very high, and in upper extremity, upper part above the level of the heart, the pressure is low. And this is because of the effect of the gravitational force. A similar condition is observed to some extent in lungs also. So pulmonary vascular pressure varies in different part of the lungs. And finally, respiratory movement introduction. Respiration occurs in two phases, namely inspiration and expiration. And during inspiration, thoracic cage is enlarged and the lungs expands so that air enters the lungs easily, and during expiration the thoracic cage and lungs decrease in size and attain the pre-inspiratory position so that air leaves the lungs easily, and during normal quick breathing, inspiration is active process and expiration is the passive process. So muscular respiration. Respiratory muscles are two types, inspiratory muscles, expiratory muscles. Now, however, respiratory muscles are generally classified into two, primary or major respiratory muscles, which are responsible for change in the size of the thoracic cage during normal quick breathing. Second, accessory respiratory muscle that helps primary respiration muscle during forced respiration. Inspiratory muscles involves in the inspiratory movement are known as inspiratory muscles. Primary inspiratory muscles are the diaphragm, which is supplied by the phrenic nerve C3 to C5, and external intercostal muscles supplied by intercostal nerves. Accessory inspiratory muscles, sternocleidomastoids, crani, anterior serrati, elevators to the scapula and pectorals are accessory inspiratory muscles. Expiratory muscles are primary expiratory muscles are the internal intercostal muscles which are innervated by the intercostal nerves. And finally, accessory expiratory muscles are the abdominal muscles. So movement of the thoracic cage. Inspiration causes the enlargement of the thoracic cage. Thoracic cage enlarges because of the increase in all diameters, while anterior-posterior, transverse and vertical diameters, anterior-posterior and transverse diameters of the thoracic cage are increased by the elevation of the ribs, and vertical diameter is increased by the descent of diaphragm. In general, change in the size of the thoracic cavity occurs because of the movement of the four units of the structure. Number 1, thoracic leads. Number 2, upper costal series. Number 3, lower costal series. Number 4, diaphragm. So number 1, thoracic lead is formed by the manubrium sterni and the first pair of the ribs. It is also called thoracic operculum. A movement of the thoracic leads increases in the anterior-posterior diameter of the thoracic case, and due to the contraction of the scalene muscles, the first rib move upward to a more horizontal position, and this increases the anterior-posterior diameter of the upper thoracic case. Number 2, upper costal series is continued by second to third pair of the rib, and movement of the upper costal series increases the anterior posterior and transverse diameter of the thoracic case. Movement of the upper costal series is of two types, pump handle movements and Beckett handle movement. Now pump handle movement, it is contraction of the external intercostal muscles causes the elevation of the ribs and upward and forward movement of sternum, and this movement is called pump handle movement. It increases anterior posterior diameter of the thoracic case. Now second, buccal handle movement. Simultaneously the central portion of these ribs moves upwards and outwards to a more horizontal position, and this movement is called buccal handle movement, and it is increased in the transverse diameter of the thoracic case. Now third, lower costal series includes 7th to 10th pair of the ribs. Movement of the lower costal series increases the transverse diameter of the thoracic case by buccal handle movement, and buccal handle movement, lower costal series of ribs also show buccal handle movement by sweating outwards and upward, and this moment is increased the transverse diameter of the thoracic case. 11th and 12th pair of the ribs are floating ribs, and these ribs are not involved in the changing the size of the thoracic case. Now diaphragm increases the vertical diameter of the thoracic case. Normally before inspiration and diaphragm is dome shaped with convexity facing upward, and during inspiration due to the contraction muscle fibers are shortened, but the central tendinous portion is drawn downwards to the diaphragm is flattened. Flattening of diaphragm increases the vertical diameter of the thoracic cage. And now movement of the lungs. During inspiration due to the enlargement of the thoracic cage, the more negative pressure is increased in the thoracic cavity, and it causes expansion of the lungs, and during expiration the thoracic cavity decreases in size of the pre-inspiratory position, and pressure in the thoracic cage also comes back to the pre-inspiratory level, and it compresses the lungs tissue so that the air is expelled out from the lungs. Now factor causing collapsing tendency of the lungs. Two factors are responsible for the collapsing tendency of the lungs. Number 1, elastic property of the lungs tissues. Elastic tissues of the lungs shows a constant recoiling tendency and try to collapse the lungs. Number 2, surface tension. It is tension exerted by the fluid secreted from the alveolar epithelium on the surface of the alveoli membrane. Fortunately, there are some factors preventing collapsing tendency of lungs. In spite of the elastic property of the lungs and the surface tension in the alveoli of the lungs, the collapsing tendency of the lungs is prevented by two factors. Number 1, intrapleural pressure, and number 2, surfactant. Number 1, it is intrapleural pressure. It is the pressure in the pleural cavity, which is also negative, always negative, and because of the negativity, it keeps the lungs expanded and prevents the collapsing tendency to the lungs produced by the elastic tissue. Number 2, surfactant, and it is the substances secreted by the alveolar epithelium, and it is reduced surface tension and prevents the collapsing tendency to produce by the surface tension. Normal value respiratory pressure are always expressed in the relation to atmospheric pressure, which is 760 millimeter Hg. Under physiological condition, the intrapleural pressure always negative. So normal values are at the end of the normal respiration, inspiration minus 6 millimeter Hg. That means 760 minus 6 is equal to 754 millimeter Hg, and at the end of the normal respiration, so minus 2 millimeter Hg. That means 760 minus 2 is equal to 7558 millimeter Hg, and at the end of the forced inspiration minus 30 millimeter Hg. At the end of the forced inspiration, which crossed glottis manular minus 70 millimeter Hg. At the end of the forced expiration with closed glottis, that is plus 50 millimeter per Hg. Now, significance of the intrapleural pressure. Throughout the respiratory cycle, intrapleural pressure remains lower than the intraalveolar pressure, and this keeps the lungs always inflated. Thank you.